Hey guys, welcome to day 6 functions in Python. Imagine you are cleaning 10 different data sets, and in each of them you have to perform certain logic like null handling, column renaming, validation. Functions help in consolidating them and creating a reusable logic which you can put it at the place of your need. What is function? Function is a name block of code that perform a specific task and can be reused anywhere in your program. The technical definition is you define a function with a keyword called def in the beginning, and then you give a proper unique name to a function. A function will have certain input parameters which you can pass it as an input. Within function you perform certain logic and then return the result. So a function has a keyword to define it, a name, input parameters, logic, and a return value. Let us try to write our first function, kind of a hello world function, where we simply print a greeting. We use all the all the definitions that we wanted to put, like we define a function with a keyword and then we also give a proper name. This is called defining a function. Once the function is defined, you can simply call the function, and then you will be able to see the output. On the similar lines, let's get started. Let me just put one additional exclamation so that you can see, get a feel of the function is producing some different output. Let's run the function and then let's again call the function. Okay, now this function can be used within a loop as well. What I've done as a part of this video is I have put like different ways in which the functions can be defined in Python in the context of data engineering. Let's start with the first one, functions with parameters. As I said, a function takes input parameters. We'll define a function where two different input parameters are coming in, something called revenue and cost. Once those input parameters are in, the values are subtracted. Revenue cost is subtracted from revenue, and profit value is calculated. Once the value is calculated, we can return that value. This is how we define a calculate profit function. Now let's call the calculate profit function. The moment we call the calculate profit function, we can see that the value of profit is calculated and returned, which we are then assigning to a variable and printing it. So this is how we can pass input parameters to the function. Now there might be a situation where you are not passing all the parameters. So Python doesn't ask you to pass all the parameters to the function. Otherwise in a language like C++, you need to pass all the positional argument. But here you don't have to pass. This is again another beauty of Python being used in data engineering. Now let's write a function called calculate tax in which one parameter is amount and another parameter is rate. There is a default value already given to it. Now when we call the function, we can call it with one parameters or we can call it with two parameters. If we call with one parameters, then the default value is used to calculate the result. But if we don't pass it, then it uses the new rate for calculation. So let's change the value so that you can feel that there is a change of result. See, we passed 10,000, so it will use the original value of 0.18% and calculate the tax. On the other hand, if you pass 25%, it will override the value of 0.18 and it will calculate 2500. Moving to next set of flavor is returning multiple values. There are many situations in data engineering pipelines where you need to return many values because you can't afford to call a function again and again, or uh, just to get the different values. Correct? So Python provides that facility. Let's check this function called compute matrix in which the profit and margin is calculated and both of them are then returned. This is the definition of compute matrix, and here is the call to a compute matrix function where we simply pass input, and once the inputs are passed, we get two values in return, profit and margin, which we can collect into different variables and then print that out. Moving to next set of things, using functions in loop. Once you define the function, you can simply use that in any of the if condition and in any of the loops. Here you can see the function called evaluate sale. In the function called evaluate sale, the amount is passed and the function is simply calculating whether its returns are high or normal. Once we execute it, the once we execute it, the values are then calculated and printed. So for example, the for loop iterates over the entire array and it will pass one value at a time. Evaluate function will calculate this, categorize and calculate the return and simply print that out for you. Moving to next flavor, keyword and positional argument. There is a possibility that you may or may not have values for all the variable input to the function. For example, this function called describe customer takes two arguments. One is name and another is country. What you can simply think of is, let's say you may have name but you may not have country. So you may not want to pass that out, right? So in that case, it should be it should be kept as an optional, correct? So positional argument helps you do that. And we may not want to maintain that sequence, correct? But uh, if we don't do this, then what simply will happen is it will assume that whatever is the first coming value is the name and whatever is the second coming value is the country. So if by mistake we pass first value as India and second value as John, then it will assume that the first one name is India and country is John. This is the kind of problem will happen when you are and this is a very practical situation in Python. While building the data engineering pipeline, there are numerous number of arguments and you may or may not have the right set of value, and then you have to properly maintain that sequence. If you don't want to maintain that sequence, the simple answer to that is you just pass the keyword. So you know that name is something which you are passing, then simply name it. If you name the input parameters, then you may not have to define them. And what how it helps is, if you don't you have the liberty of passing it in any sequence. This avoids a lot of mistake. So passing the keyword plays a very critical role in avoiding mistakes of assigning a wrong value to a wrong variable. Moving to the next flavor of things called star args and star star kw args. This is useful in the case where input is not known, that how many positional argument you are going to get is not known, and this is a very valid situation. Let me give you an example of a practical situation called in Python. In Python, there are in Python Airflow, when you are writing a code, there are many times a situation where you don't know how many keywords the user is passing. In that case, the keyword args plays a very important role. Let's take an example of each one of them. For example, if the total amount that is coming is not known, the number of amounts are not known, then we simply give a star. This is enough to signal to the Python engine that the number of arguments that are going to come is not known, and it is going to simply collect all the incoming values into a single variable and then use that accordingly. So let's print this out. It is going to sum these values up and going to print the sum. The way these are the single arguments and number is not known, similarly there might be a situation that there are key value pair and key value pair number is not known. The example which I just gave is Airflow having key value pairs and you don't know how many values that you are going to get. In such case, giving two stars helps. One star defines single values that are coming, single but multiple values, but two star define key value pairs but multiple. So info can have as many key value pair as possible. Let's simply put it as let's call it as mm, John's salary equal to 50k. We can simply run and print that out. So even if we increase the key value pair, we didn't have to make any change to a function, and within single variable info, it is able to accommodate this additional variable as well. Just by giving simple 2 star, you get this facility. This is the power of Python, and this is very useful because many times in data engineering pipelines, the incoming data set length is not known. That is where these are useful. Based on this, I have prepared one data validation function where we are just validating the record. What validate record does is it will check whether the ID column is having a valid value or not, or a record amount is less than or equal to 0. And if any one of these is true, then it is going to say that it is an invalid record. This is a record set which we are going to evaluate, and then simply we will iterate over it. The moment we start iterating over it, we realize that the first record is valid, whereas the other two, where the amount is not valid, and the third one is where ID is not valid, are the invalid records. We simply run this and print that out. What happened is we called one function called validate record over all the records within the within the dictionary, and we are able to print the results. This is the power of validate record function. Now what we in future, if we have to add any condition, we don't have to make changes in all the code. We simply evolve the validate record function. This is another set of thing where a function returns another function. So for example, this is where there is a function called multiplier, and upon being called, it will return another function. For example, multiplier returns multiply, in which the factor is the value is then set automatically. So here, let's say when the multiplier function is called with the value, let's give it as 3, we will have a function. This variable will contain a function called multiply with a value of 3, value being already defined as 3. And when you call this with an argument, what you will get in return is a multiplication of the factor and the value, and what you will get in return is the answer, which is 60. 20 into 3. This is again very useful when you have to define multiple functions. You can use this way of this advanced way of returning function from another function. Just to wrap it up, we can see there is something called build your ETL pipeline with the help of function. When you are building a very complex system where you have to segregate the things logically, then you need to divide it into function. This is one example of it. Let's say we are building an ETL and we simply write an extract, transform and load function. What extract does is it is going to get the values. So we have simply hard coded an array here just for showcasing it. Transform is something which is going to receive sales array as an input, and it is going to perform some sort of an action, kind of a filtering. There is conditional filtering is being performed by transform, and then the things are then loaded and counted. So let's do one thing. Mm, let's let's make one value more so that you can see a different result here. What just happened is, first extract is called where we received all the data. Then filtered transform is called where we filtered the data based on the condition that the value is greater than 10,000, and we can see that three values are greater than 10,000. And then in load, we simply loaded that into a variable. We can load it into a destination, but here we have loaded it into variable. So this way you can very beautifully divide the divide your logic into functions, and it can help you to generate an amazing maintainable code. Functions are extremely powerful. Writing your code into functions always help you to write a maintainable thing. As you always say, it is very difficult to create simple things. and functions are the pioneer for this. Thank you for listening. Please do subscribe.